Good morning, ladies and gentlemen. Hope you all are having yourself a wonderful Wednesday morning. I'm doing quite well. I had just had a cat on my lap, but I guess she's camera shy. But we're really wrapping up with the basics of probability, so I wanted just to spend today talking a little bit about independence. And talk about mutually exclusive events and how your numbers can change depending on what you're trying to achieve with your probability. But let's jump into this. Now, I think at this point we would be able to solve these. You guys should be able to solve these on your own, considering when it comes to independent probability, it's just, E over T. But let's work on this one as a team. And I'll point out things that you should be working on. In a department store, there are 120 customers, 90 of whom will buy at least one item. If 4 customers are selected at random at the same time, find the probability that they will buy at least one item. Why did we emphasize at the same time? Well, ladies and gentlemen, emphasizing at the same time, it's because we want to make sure if we pick one person, we don't pick them again. That's really why we don't want to complicate our probability, saying, okay, if I'm picking 4 people at the same time, well, I don't want to pick the same person multiple times because that will just totally throw off my data. So, what's the probability that somebody will buy at least one item? Well, if we use this E over T, we should think about, okay, what's my E, what's my T? 90 over 120. Now, ladies and gentlemen, I'm going to put this probability of 1I for one item. Now, that might be the probability of one person buying one item, but what can I do with this? Well, I could certainly simplify it, because if that's a 0 and that's a 0, I can just get rid of the zeros and boom. 9 over 12. But could I simplify that again? What if I were to divide the numerator and the denominator both by 3? What's 9 divided by 9? Well, what's 9 divided by 3? 3. And what's 12 divided by 3? 4. And so this is my lowest probability. That's the probability that if I select one person, that they're going to buy an item. Now, if I want to have 4 of them, am I going to just do this 4 times, like 3/4 plus 3/4 plus 3/4 plus 3/4? Well, obviously not, because I can't have a probability greater than 100%. So I can't add them. What if I multiply them? Well, can I multiply them by 4? No, same thing would have a problem. Multiplying this by 4 would mean I would have 12 over 4, and that just gets me the same problem. So I can't add them all up. I can't multiply them by 4, but what if I were to multiply them together? That would still keep me less than 1 and still account for having 4 different customers. So this could be the probability of 1I times the probability of, I'm not going to write that one out fully out because I don't know if I have enough space. It's the probability of one item to the 4th power, because I have 4 customers, so that is 3/4 to the 4th power. And that's going to be 3 times 3 times 3 times 3, which is, 3, 9, 27, 81. And 4 times 4 times 4 times 4 is 4, 16, 64, and 256. Now, ladies and gentlemen, I did do this earlier, and I'll tell you, I don't think you can break down 81 out of 256, and so that is our answer. If you were to select, if you had 120 customers and you were to select 4 of them at the same time, the probability that they all will buy one single item, at least one item, will be 81 out of 256. Oh, excuse me. Apologize about that. I'm a little groggy this morning. Of the 216 players on a Major League Soccer roster, 25% are U.S. citizens. If 3 players are selected at random for an exhibition, what is the probability that 2 are U.S. citizens? Now, ladies and gentlemen, there's 2 ways that I think you could really approach this one, but they should all come out to be the same thing. Give me just a moment. Now, you might say, okay, well, this is E out of T, or at least the probability of 2 players are E out of T. Actually, 2 American citizens. I'll put probability of A for America. Well, this has to deal with, okay, well, that's got to be some sort of E out of T. Well, what's going to be your E? Well, you know your T is going to be 216. Well, what's 25% of 216? Well, 25. If you multiply that out, you'll know that 54. And so that would be a probability that you're working on, except they already actually just tell you the probability. The probability is 25%. And so this has to boil down to 1/4, which is equal to 0.25. That's the probability that someone is an American on the soccer team. Well, okay. Probability of A. So I'm going to kind of nix that all out, cross that all out. Except there's 3 of these people, right? And I want 2 of them to be Americans. So that's going to be 1/4 for 1 American. 1/4 for the next American. And if the last person is not an American, what do they have to be? Well, it's got to be 1 minus 1/4. Which would be 3/4. And so that'd be 3/4. Because they are what we call complements. And so if I multiply this out, well, 1 times 3 times 1 is going to be 3. And just on the previous page, we know that's 4 times 4 times 4 is 64. Ladies and gentlemen, you cannot break that down further. That, if you want to know what the decimal of that is 0.0469. So the probability of having 2 Americans on your soccer team, if you select 3 of the players randomly, is a little below 5%. Alright, now we're going to tackle something a lot harder, so I definitely want you guys to pay attention. Because we're going to combine independence, or really, we're going to combine, that's still independent and dependent events with mutually exclusive events. Meaning you have to have things that are not in the same category. Now, suppose a cooler has 6 Powerades that are 3 red and 3 blue. Further, suppose that the same cooler has 5 Gatorades, 3 red and 3 blue. Now, personally, I prefer Powerades. But, we're not going to go into my personal preferences on this. But the point is, in this cooler, we have two different types of drinks. They are mutually exclusive because if you have a Powerade, well then a Powerade's not a Gatorade, and if you have a Gatorade, well that's definitely not a Powerade. We want to determine the probability that if you reach for 2 drinks, the second one is blue. If you reach for 2 drinks, that means the second one is blue. Well, let's figure out how many blues and how many reds we have. And keyword that the second one is blue. We don't care about what the first drink is, but we care about what the second drink is. Well, if we do this, how many blues do we have? 3 blues and 2 blues? Well, we've got 5 blues. And 3 reds and 3 reds, we got 6 reds. And so you might want to say, well, if the second one is blue, well, then if you just multiply them out, multiply a red and then a blue, well, then boom, you get what you get. But that's not what's going to happen here. Because if you're reaching for 2 drinks, it's obviously dependent, right? Because your first drink is going to affect what your second drink is. And we don't... What if you draw a red one on the first one, and what if you draw a red one on the second one? You do have to do a bit of an addition here. Because you have case 1. Let's say case 1 is you get a red on the first try, and case 2 is you get a blue on the first try. Well, let's just consider case 1. Well, first one is obviously going to be a red first. Oh, let's put this one together. Totally, you have 11. Alright, well, case 1 being red first, that one is going to be, alright, the probability of getting a red first is 6 out of 11. And then, obviously, your second one has to be blue. And this will be red, and that's going to be blue. Well, you have 5 blue, but you now only have 10 drinks in there. Case 2, on the other hand, says, alright, I'm getting a blue first, and then my second one is also going to be blue. So that one is going to be 5 out of 11, and then 4 out of 10. Now at this point, you got to be very careful on how you multiply now these ones out. Remember to multiply across. If you simplify this and multiply it together, I just want to make sure, alright, I do have something there, so I'm not really going to... Yeah, I'll write over it. If you multiply these together and simplify it, you should get 2... Oh no, this one's going to be 3 out of 11. Eraser's my friend. Get 3 out of 11, and this one should get you 2 out of 11. Because this is 20 over 110, which simplifies down to 2 over 11. If you multiply these together, you get 30 over 10, or 30 over 110, which just simplifies down to 3 over 11. Now, you have 2 11s plus 3 11s. You add those up, you get a total of 5 out of 11. Now, this one is entirely different because you have 2 different cases. If you reach for 2 things, well, what's the chance that your first one is a red? And what's the chance that your first one is a blue? You could have 2 different possibilities, so you have to consider both possibilities. Now, because these are mutually exclusive, they're different, you add them up at the end. The way I would do this is first, figure out what your individual probabilities are for each case. Well, really, the first step should be identify your cases. What if you draw red first, or what if you draw blue first? That's step 1. Then figure out your individual probabilities, that's step 2. Remember that they're dependent. Most likely that they're always going to be dependent. Because, alright, what if I draw blue first? Well, then I've got less blues. Or if I draw red first, then I've got less total Powerades, or less total Gatorades. Once you do that, step 3 is multiply your stuff together. Step 4 is simplify. Alright, for this last one, let me at least start you off. And then I'm going to, well, actually, I'm going to tell you at the very end. Your answer should be 2/3. Alright. At a co-ed volleyball game, there are 4 guys and 8 girls. Love volleyball. Volleyball is like my favorite sport to play. When picking teams, they select players one at a time. What is the probability that the second player picked will be a girl? Once again, this is going to be dependent, mutually exclusive. Because how many total players do you have? You've got 12 total players. You've got 4 guys, 8 girls. And you don't care about who the first player is going to be, you only care about who the second player is going to be. So you have to work on a case 1 and a case 2. And let's say your case 1 is you pick 2 girls. Well, that's going to be 8 out of 12 if you pick the first girl, and it's going to be 7 out of 11 if you pick a second girl, because you're looking for the second player to be a girl. Case 1 or case 2 is if you pick a boy first. Well, pick a boy first, that's going to be 4 out of 12, and then 8 out of 11. And then, once again, multiply, simplify, get your answer. All right, ladies and gentlemen, tomorrow we're going to continue on this train of thought, and we're going to be playing around with a lot of different cases of probabilities. Remember that this is just the basics. We could be going a lot more into probabilities, but I want you guys to be able to walk before you can run. All right, ladies and gentlemen, hope you guys all have yourself a wonderful Wednesday.